Good evening, everybody, and welcome to our webinar series, Dwelling Drupal 8, an exclusive series on Drupal 8 and Drupal and related technologies. Innovative Solutions is a software development company with specialization in Drupal development services. We use open source technologies such as Drupal CMS, Falcon, and other platforms to build robust, cost-effective solutions. Our digital and Drupal approach enables us to provide contemporary business solutions and incorporate rich media in contemporary layouts and schemas. Harnessing the power of Unity's proprietary analytics and simulation engine, we capture user preferences to link to personalization module with the default delivery to web and mobile app. Today's session is on deploying Drupal in AWS for scalability and high availability by Karthik. Karthik works as technical lead systems at Unity Solutions, and he has been supporting an infrastructure for the past 10 years. He worked for many Drupal sites, especially in Linux and Windows environment. He's an expert in configuring and optimizing the LAMP environment for high traffic sites. Also, he's proficient in understanding how various caching and infrastructure layers work with Drupal and optimally using them. Karthik has also been part of project management, starting from setting up initial project workflow throughout identifying hosting services, recommending infrastructure, load testing, and launching. He is versed with technologies like AWS Cloud, VMware, and Docker, etc. So Karthik, welcome to our show and thank you very much for joining us.
Thank you very much, Jaya. So today's session is all about deploying Drupal on AWS for scalability and high availability. See, today's modern business requirements is like the system should up and run in 24/7 without any fault tolerance or without any downtime. For that, we need a optimal infrastructure. So today we are going to have a quick view on how we can deploy a Drupal application in AWS with high availability and scalability. What is high availability? High availability is nothing but there should not be any single point of failure. So, we have a lot of different kind of components we used in the infrastructure layer. So there should not be any kind of downtime in any kind of components. Even if any one component fails, the whole application get collapsed and we are not able to access, and the business requirement will not meet the requirement. So we should have a high availability as well as scalability. Scalability is nothing but it should perform even more number of users are accessing. So for that, actually in AWS there is a feature called auto scaling is available. By using that feature, we can scale up and scale down the instance automatically without any manual intervention. So by deploying Drupal in AWS, we can achieve high availability as well as scalability. So high availability is nothing but we can deploy the application. Different.
It's okay, Karthik. Just it's. I guess it's a small disturbance.
Yeah. Okay.
Just a second. Shiva, could you please mute your microphone? Shiva? Yeah, Karthik, please continue.
Okay. Yeah, thanks. So high availability is nothing but we can deploy the application in different zones in the AWS infrastructure. There are different regions available. In region, we can have a minimum. We can deploy the application in minimum in 2 zones, so that we can meet the requirement of high availability. So first of all, before going into high availability or scalability, first we need to do the application should be loosely coupled. Only then we can achieve the high availability, as well as we can easily scale the application in different layers. Uh, so in this, actually, we have split it like this. Like we should have a HTTP, that is web server. There will be a PHP processing, application code, static files, cache, user sessions, a database. So first of all, we need to understand these things to do the high availability as well as scalability. So actually, we can deploy the Drupal application in AWS using this kind of components. So first of all, before deploying the application, we need to configure the servers, like web servers. The web server we can configure in either two ways. For example, if you take Apache, we can configure as a prefork mode and worker mode. So basically, for high availability and high concurrent users, we should do a loose couple, as I said earlier. For doing that, we need to understand the application needs and business needs. So if more number of concurrent users and there will be a dynamic thing, so we should consider using Nginx as a web server. So if we use Nginx as a web server, so Nginx will serve all the static contents. So we need a PHP processing thing. So if you're planning to use Nginx as a web server, we need to use PHP fast SCGI. So by using like that, what will happen is the PHP will be executed only when PHP will execute, the fast CGI functionality will work. For static files serving, the Nginx will serve the static files. So by splitting like this, we can reducing the memory consumption of the web server. So traditionally we use actually as Apache as a web server using more underscore PHP. It's nothing but the PHP and the web server is tightly integrated. In that case, what will happen is, suppose if you are requesting a PHP request and suppose it consumes for that particular request for 10 MB. Again, next request is as a image request. That request will only consume, for example, 2 MB. Anyway, since it's a tightly integrated, what will happen is, again, it will take only 10 MB because all the parent request is already used 10 MB. So till that parent request closes all the child request, you end up using with 10 MB. So the memory will not get released. So what will happen is, so again, if more number of requests is coming, again, it will consume more and more and more memory without releasing it. So in that case, the server gets hanged and everything will be collapsed. So that we should understand the business requirement and configure the web servers as a Nginx as a separate and PHP processing as a separate thing. Only then it will consume lesser memory and we can have configure as we can PHP will consume only lesser memory, so that we'll have other memory for other process. So by doing loosely coupling the different layers, we can easily scale the instance. Suppose if we, as I said earlier, if we configure Nginx and fast CGI in the server and splitting the things, we can add a vertical scaling by adding another server, and we can deploy the codes over there, and we can easily scale the instances. So as I said, we should loosely couple. So we should separate the static files into separate things. So I'll explain detail in the next slide. User session, we can since user sessions are stored in the database in Drupal. So all the users request also go into the database, and it will hit the load to the database. So we can offload by putting the sessions into the memcache or any caching layer, and we can offload the database load. The following diagram shows the architecture of the high availability and scalability for Drupal application. So in this, I can explain you in detail in all the components which we have used in this architecture diagram. So to do the high availability and scalability, we need a load balancer, which will route all the traffics to different web servers. So basically, I can explain you the things. This is actually a overall high-level architecture diagram. In this, there is a virtual private cloud. So in Amazon, there is a feature called a virtual private cloud. So by using this virtual private cloud, all the security is taken care by the virtual private cloud software. So we are deploying our applications, and we are creating all the instances, hardware, everything in the virtual private cloud, so that everything is secured and dedicated for us. So first we'll take a look of the overall high-level architecture of this diagram. So first of all, we have configured all the instance in 2 availability zones. For example, there are 2 availability zones here, availability zone A and zone B. We have configured that web instance, that is Nginx and fast CGI in web 1, as well as in web 2 in availability zone 2. We have configured as static files asserts in EFS. EFS is nothing but elastic file system. This service is provided by Amazon. So once you want to do a load balance thing, first of all, from the Drupal code, we need to detach the static assets and put it in the start location, so all the web servers can communicate to the storage assets. So in that will actually managed by Amazon. You will get a 99.99% uptime from the shared files for static files. So by doing this kind of architecture, we'll get a high availability and high scalability. So for example, if someone request comes to the web 1, it will hit the web 1 web application here, and then it will hit the master database. And if suppose master database goes down, it will automatically, the standby database will get configured as a master, and the master database will act as a slave once it comes up. So by this, we can achieve the high availability. For the web instance layer, we have configured an auto scaling part. So based on the policy settings, it will automatically spin up the instance. For example, if the web layer is reached 90% of CPU, then automatically trigger another web instance. Like that, we can set a policy. Based on the policy, the auto scale will spin up and it will come into the load balancer. So as I said earlier, the elastic cache is a vital role here. It will actually offload all the database layer. So what we can configure in a elastic cache in such a way that all the caching part can be configured in the elastic cache, so that it will offload all the database thing. So that you will get the this database maintained in the so that the database can be maintained in normal CPU usage as well as the memory usage thing. Okay, so now we'll go into the deep level into the component things. So now we have in earlier slide we have shown a load balancer. Now we can see how the load balancer is configured. So first of all, we need to configure the load balancer in such a way that the loads are distributed equally to the web instances. So for example, now we have used in the Amazon's load balancer. So the load balancer is using a round robin algorithm. It will route the traffic to the EC2 instances, web instances. So based on the request, it will route the traffics. So basically from load balancer, it will route to the zone A, that is web 1 instance. Next request comes in, it will route the request to the zone B. So based on the round robin algorithm, it will route the traffic. So the load balancer also will elastically grow. That is actually taken care by the Amazon thing. So next is we need to configure the load balancer to check the instance health. So we can actually ping the the EC2 instance. We can ping the EC2 instance and check the instance uptime. If the response is not getting from the instance, we'll automatically terminate that instance and we'll add one more instance from the image. So in the add instance part, you can see what are all the instances added over here. Next is actually security groups. This is a vital thing for security thing. Security is from where the request can come and from which instance it goes to the request. So in the security part, we can configure which all the instance is allowed to and which instance is not allowed. So we can configure the securities as per our business requirements. Next is auto scaling part. So in we will see in depth of auto scaling thing. So auto scaling is actually what is the main purpose of auto scaling? Actually, in olden thing, that is in legacy system, what we will do is we'll procure a high level kind of systems for business requirements. Say for example, say we'll get suppose if we need only once in a while, we'll get a high number of concurrent users. So for that, we'll procure a high memory configuration and CPU configuration systems. So now in modern thing, that is cloud advantages is whenever the business demands, we can auto scale the instance by using this auto scale feature. So If demands requires, we can scale in. If the demands meets the requirement, we can scale in. If not, then we can scale out the instances. So this is the auto scaling configuration part. First of all, before doing the auto scaling, we need to, do a launch configuration. Launch configuration is nothing but which instance we should auto scale. That image we need to map in the launch configuration. So this launch configuration cannot be changed at any point of time. So if you want to change the image later, you need to create a new launch configuration in auto scaling configuration management. So these are the AMI ID is nothing but the image which we have already stored for that particular instance. Then IAM instance profile is a profile name for that particular instance. Next is auto scaling group. So first of all, we have to create a launch configuration, and then in this auto scaling group, we have to map that launch configuration. Once we map the launch configuration, based on this auto scaling configuration, it will take the launch configurations image and it will, based on our requirement, it will scale in and scale out. In this auto scaling configuration, we have to configure desired instance, like how many instance minimum it should run at any given time, and maximum instance how many can go in auto scaling, how many max instance can be turned on. So this configuration parameter we have to specify here. In this tab also we need to specify the scaling policy. That scaling policy is the vital thing here. So based on this policy only, the auto scaling part will work. So in the scaling policy, we need to configure scale up policy as well as scale down policy. So there are different type of parameters available for scaling up and scaling down. We can use CPU, we can use disk usage, we can use memory usage, etc. The same kind of thing for scaling down also. We can use CPU, memory, disk, etc. So based on the policy configuration, it will scale up and scale down. So in this also, in the instance tab, it will show currently how many instances are scaled up and how many instances are scaled down. And in monitoring tab, we can see the parameters for auto scaling. In notification tab, we can configure the notification whenever a system triggers a scaling policy or scale out policy. So we can see the notification over there. So there are two kind of thing is available here. One is based on the scaling policy we can trigger. Also based on the scheduled actions we can trigger. So in given time, if you want to scale up, so we can put it in the scheduled action that this particular time I need 3 number of instances to be scaled down, or 3 number of instances should be scaled down. So we can configure in a scheduled action also in the auto scaling part. Next slide is code deployment. So first of all, we should have a proper code deployment so that we can easily scale up and scale down the instance. So whenever an instance is scaling up or scaling down, a new instance is creating. So then if new instance is created, we need to automatically deploy the code, install all the necessary softwares over there, and bring the system into the load balancer. For that, we should have a code deployment process. So code deployments automates deployment in Amazon EC2 instance so that there won't be any downtime. Whenever an auto scaling feature is requested, the code deployment will deploy the codes and attach to the instance will automatically attach to the load balancer. So before deploying the code, first we need to understand how we can deploy the code. So first we have to deploy the source code in a GitHub or any version control service, whether it is a cloud service or in-house. Once we deploy the code over there, we should have an appsec.yml file. In the appsec.yml file, we'll have to mention the source from where the code needs to be deployed. So whenever any actions triggered in the Git, it can automatically push the code to the instances. So there are different kind of configurations and methodologies are available to deploy. So in our case, what we have to do is, so whenever a auto scale is happened, we need to deploy the code to the particular instance. So for that, we have configured a appsec file. So first thing is actually a source is deploying into the destination folder in the server. Then that is a hook scripts which will run once the deploy is completed. In that scripts, we can restart our required services. For that, we can put that post scripts and all. So this is the code deployment configuration for auto scaling. So once we go to the AWS control panel, you can configure the code deployment for auto scaling purpose. So here we are actually doing a auto scaling for high availability and scalability. So if any actions triggers for the auto scale, the code will automatically deploy from GitHub to the Amazon's AWS instance. For that, we need to configure the code deployment service as an auto scaling group, and we need to map all the instances over here. Once we map the instance here, any triggers happen by the policy which we have set, then automatically what will happen is the code is pushed to the instance from the version control. Next part is actually database for that particular Drupal instance. So for high availability, we should deploy the database in multi-availability zone. Once we deploy the database in the multi-availability zone, what will happen is the master, the slave replication will happen. Whenever any updates goes to the master database, it will automatically replicate it to the standby database. So we have, for any kind of production application, we have to use multi-availability zone so that you will get a online replication. If master fails, automatically the slave instance will act as a master and you won't get any downtime. So that you should use the master slave setup in Amazon's RDS service. This screen shows the configuration of a MySQL database using multi-availability zone. The configuration details tells you about what is the host name for to use the database, and what is the MySQL version you are using it. So an optional group, that is MySQL default group and parameter group. The most important thing for high performance is we need to fine tune the MySQL database parameter. So first we have to run a few scripts to understand how the MySQL parameter is configured. Based on that output value, we need to configure the MySQL parameters, and then we should make the instance live. So now currently this slides in the configuration shows the database instance is configured in the multi-availability zone, and primary zone is in different zone and secondary zones in different zone. So whenever you configure a multi-availability zone, your database will be replicated to different zones, so that even though if one zone completely is not accessible because of any hardware failure or something like that, you will route it to the another zone automatically. So your application, there won't be any downtime for your applications. That is the biggest advantage of MySQL RDS in Amazon. So we have deployed the Drupal application in, that is Drupal database in MySQL RDS. So these are the parameters configuration for MySQL. So we need to fine tune this configuration and reboot our MySQL instance to affect that configuration. So basically that MySQL storage engine should be InnoDB, so that all the tables will be row level locking. So you get a bigger advantage of that to the MySQL thing. Thank you so much.
So, viewers, you can ask any questions if you have any doubts to Karthik. Any questions? Okay. So thank you so much for joining us. You can always tweet using hashtag #dwellingruplet if you have any questions. Also, Karthik will be available to answer you immediately. So, and our next session will be on 11th February by Vijay Chandran Mani on microservice in Drupal 8. So see you next time and have a good night. Bye bye.